How about now? Well, I'm super sorry. So all the amazing things I explained at the beginning of the stream are all lost. Sound is working now? Ah. Well, Mikey, welcome to the stream. I'm very sorry. Patsir, again, welcome. I'm very sorry. Very quick recap of the first, I don't know how many minutes of the stream. Last weekend, I manufactured the spoil board. The spoil board has a 5 by 5 centimeter hole pattern in M6. And I basically, how this works is that this is like a 3D model of the spoil board. So this base layer here is an 18 millimeter multiplex wood. And this is just the MDF piece. The idea is basically that I never have to replace the multiplex and only have to replace this MDF, which is relatively quick and easy to do. On the bottom, I machined these holes so that these drive-in nuts, as I showed at some point in the beginning of the stream, like these are sitting in there. So these are basically in these holes on the bottom. These are M6, so I can basically use them. You can see it to add fixtures to the spoil board. What else? Yes, the goal now is actually to machine this part. This is what we are doing now. We are machining this part. What I also said is I somehow lost a part I printed, and I wanted to reprint that. So I will just quickly start it again in the background. Okay. Then, yeah, sorry for all the chaos. Like, I don't know why the microphone was not working. Like, I just plugged it out, plugged it back in, and off we go. Okay. So the idea basically is for this part that we first machine the 3 holes here that are later used to fix the part, or like this bracket to the board. Oh, the goal of the bracket is, sorry, I also should mention this, that if I put a part, like a machining part in here, I know the exact coordinate without having to measure every single time where on my workspace basically this part is. I do know this. I can restore the CNC to this coordinate here on the front. That's something I measured. I noted down basically the position. So I now homed the CNC. And if we go to the controller on CNC, like I didn't save it yet, but like in my history, I have this very handy script here. So it's G28XY. We did it now. And then basically I move to this coordinate, and then I set the kinematic position to X0, Y10. And that means that if I'm running this now, and it just touches here the front actually. So the CNC is now basically exactly in line with these 2 holes. These holes that you don't see because like there's this plate on top, but like we are basically now exactly here. And we set the 0 coordinate now to the front here. So we now are in the coordinate system of this spoil board. That was kind of like the whole idea. Let me lift that a little bit up just for my personal comfort. I can't do too much actually. And I think we should also, so now to calculate this, because I want now to set basically my 0 point maybe in here. Let's quickly jump to the manufacture tab. and we want to manufacture this part here. This one. I think I created a setup for this. Yeah, so this is our thing we want to do. Let's quickly see. I'm not an expert with this yet. Where can I set the stock offset knob? Oh, I can just click here. Okay, so we can basically set the XY origin here in the corner. That means basically what we can do, we need to find this hole and then we can move the CNC to this corner position here. And the idea is basically if we manufacture these 3 holes, that they are exactly above the holes in the spoil board and we can fix the part with the M6 screws basically in place. So we need to do some calculation. Let's first go over this hole. That means I'll do it in design tab because maybe it's a bit easier there. We need to go over this hole. So I need to have the center, like if I select a hole here and then to the front is 96 millimeters. Let's ignore the 0.005. But we need to go to the center. And now it's measuring from the front. So the radius is 4. Let me move to the view. So the distance is 96, the radius is 4, so we need to move exactly 100 millimeter. So the Y position of the center of the hole is 100. Let me just move the CNC to 100. Y. So that would be now in the center. Check if it works now. Yeah. So this is now basically in the center of this hole. But we are currently above this hole here. The spacing is 50. So we need to move over 50. So we move to minus 50x. And now we are exactly over this hole. And that's only because I know that, like, how to restore the coordinate system of that scoreboard. Then, if we show this part here in the origin point is here in the corner, right? So we need to go from the center of this hole. So the radius is 6.5 and the distance is 3.5. So that's 10 millimeters. So we need to go 10 millimeters minus 10 in X and minus 10 in Y, and then we hover over the 0 point of our coordinate system. So I go 10 over and 10 over. So that means now the CNC is exactly positioned now over the point that we want to treat as 0. So I will now 0x and 0y. So basically now, as far as the CNC is concerned, this is exactly now where the CNC stands on the board. And this is what the CNC thinks is 0. And Fusion also will express everything as basically this being 0 of the coordinate system. Now the last challenge is basically we have to position the aluminium part that I have here physically exactly in a way that it matches what we have here. So this stock part, hi there, Ravenkeeper. this stock we can, I don't want to modify it now because now we kind of have it here. But this is 90 by 90. So it's 10 millimeters shorter in each direction, basically. You missed all the parts without sound, Ravenkeeper. I think the first 5 minutes or something, I was without sound. Okay, so the challenge now, just to check where the part is, I will just move down the tool head. At the moment, I have like an engraving bit in there. It's quite nice because it's very pointy, so we can use that to very easily see the position. And I think I'll also quickly remove the dust shoe. That we see what we are doing. Okay. I didn't build my probe device yet. Okay, so this is the zero coordinate infusion. That's a bit of a problem. Let's actually quickly remove the aluminium plate. Okay, so this is a 0 point. The main problem I have at the moment is that these clamps are already kind of at the max position. So I can completely max them out here. That's a little bit of a, like, in retrospect, I should have chosen like a more dense pattern to make that happen. Or like a more dense pattern, because like with the short clamps, I struggle to move it exactly to the millimeter where I need it to be. With the long clamps in the back, it's not a problem. Technically, we can also just use 2 clamps to position it. We use a long one in the front and long one on the back. But let's first try to make it work with these. Okay. So if we cut it like this, I fear that we don't have enough material on the back. Yeah, that's 13 millimeters from the front. We only have 10 millimeters left. So let me quickly save this Z position. And oh, I saved the Z position and moved it completely against the answer on top. Okay. That means we need to like revamp this a little bit here. I think we can only then do 2 clamps. The short clamps were a bit of like wrong purchase. I should have gotten like more of these long clamps. Back a little bit more. Okay, let's do it the following. Yeah, but that's now way too wide, way too long. I chose a really bad like distance. I think 5 is not a smart choice. Let's see how we manage. So again, we need to have it somewhere here around this region. That's quite stupid. Like from the back, it's not a problem. But like from the front, like the clamp is, these are too long and these are too short. I mean, that would work. Let me quickly move to 0, 0. Move down again. Okay, so this is 0. So I'm just gonna position. I want to have a little bit of like wiggle room, of course. So somewhere here. So I think you're actually quite in a good spot by just using a clamp as spacer. This is not how you're supposed to use these clamps, of course. But I think it doesn't matter because you only have to do this once. Once I have this L bracket here, I never use the clamps on the front again. I will not have the problem. Okay, then it means going to get this parallel. I mean, this is quite close now to the 0. Like ideally, I wanted to have a little bit more wiggle room, but I guess it is what it is. Can I get this one? I think, yeah, I can back this one out a little bit more. Use this a bit that they can rotate. Let me fix the one on the back. And let me actually like move the CNC out of the way again. Okay. One thing I didn't check now is the Y position. I think this is also okay. Okay. Sure, these are fixed. And I can use these to lamp everything down. And this is like absolutely fixed. Um, Let me quickly check again where the 0 point is. So this is now our 0 point. It's quite close to the front, but it has like 3 millimeter of space. So we can check now that it's parallel, right? By just moving over. As long as the needle stays inside the area, we are good. Yeah, and then it does. So we are now at 90, which is the end of the part, and we still have like a few millimeters to spare. So this is perfect. Ideally, should have moved a little bit more over, but that is good enough. And then when I move to Y90, and we are still over the part, we are good. So now basically we know that the whole like L bracket is inside these boundaries, which is perfect. Then the second step would now be just as a sanity check. I want to check that I find like one of the other holes. So if I move 10 millimeter back, we can actually use this crossing here. So if I move 10 millimeter back and 10 millimeter, so 10, 10. This should now be exactly over the position where we want to put our first hole. If I now move 10 centimeter over, should be exactly over this hole. And if I move 2.5 over, I should be exactly over this intersection here. So from 10, it's 10 over, and then 25 over. And now I should be exactly over this one here, if I move the tool a little bit more down. And that seems to be the case. So that means if we now drill our hole in this spot, we should be in a good position that we can basically make a hole here and then use a screw to fix in one of these holes. 1, 2, 3 screws. So let's get some tool mounted. But before we do that, let's go to Fusion and I just plan the whole operation. Okay, so first we want to make. Do we want to make a bore first? No, let's do like adaptive clearing for this, this, and this. And we want to have a tool, which, so I have a 4 and a 6 millimeter and a 2 millimeter. I think I would actually use the 4mm because I need the 4mm to drill here. I never drilled in aluminium directly. Oh, wait, I misused the setup. Oops. I'm so sorry. We need to have a new setup. We select the model, which is this one here. We have a relative, and we have 0 offset everywhere. And this is the origin point. Okay. Then we want to have adaptive clearing. Maybe Ravenkeeper, maybe you can tell me. Do you think I can just drill this 6mm hole with a 6mm end mill? Or should I use a bore operation with a 4mm one? Okay, but this is the first operation, so we do this adaptive clearing here. I do want to quickly make sure I was a little bit too aggressive in the beginning with the aluminium. So I just want to quickly make sure, like, these are 2mm deeps. So we should do this in multiple steps. So you have multiple depths here. And the maximum roughing is, let's just do 0.5. And I want to have no stock to leave. Order by area. And I think this should be good. Okay, now you see it's like doing a little bit of a different operation here. But these are these. Then let's do a bore for these holes. Is it aluminium? I've done drill with a bit, but used packing setting or whatever it's called. Both a similar bit with pocket should be viable. Well, the hole here is 6mm exactly. My bit is also 6. I think it's better to do with a 4. Like this I did before. This worked very well. I don't think we need a finishing pass here. So I think I would just do a bore, to be honest. I didn't kill a 4mm bit yet, so. Okay, so these are basically the first operation. Once we have these in place, we can remove the clamps and use screws to fix this plate in place. After that, we use the same 4mm drill bit to machine these holes. This, and this. And here, we want to drill through the whole thing. So I say offset 0.5mm. So it's, oh, there was the wrong direction. So that we go, now you see like the little like blue spirals here. So we basically go through the part into the spoilboard a bit. We should actually also do that for this one here. Yeah. If we like mess up the Z a bit, then this is what we need. And then as a last operation, then we need to switch the tool. We have a 2D contour, which is this contour here. For this one, I will use a 6mm end mill, so it's a bit bigger. And we use a ramp. Let's just use 2 degrees. Maximum ramp step down, let's do 0.8. And the clearance height doesn't need to be that high. It's like 1mm is fine because we have nothing on the board. And then at the end, you see we have this part. And then at the end, actually, let's also add a chamfer, right? We want fancy parts. 2D chamfer. So we want to chamfer these and these. Let me select the tool. Random tool selection here. Okay, I wrote the numbers on them. This is number 1. 1001. Select. And then here, like I'm still not 100% sure how this chamfering works, but if I put 0.3 here, it does a 0.3 chamfer. Now you can see like there's a little bit of a gray from the model. Now you can see like there's like a chamfer. The only thing I want to try, can I have a finishing pass there? I don't think I can have a finishing pass there. Oh, finishing overlap, 0.1. 0.005. So it should do like 2 rounds. One time it should leave a little bit of over, and then like should do a second one. That did not work. Let's try this again. Okay, so that's kind of my operation. Let's create programs from that. So basically we need 3 programs, right? The first is these 2 operations. Let's create MC program. I always call them like 1, and then I put the tool number, which is 52. And then this is 0 bracket. Let's just do 0 bracket. And then I put the same name here. And this will just pop it in my downloads every time I process that. Operations, we only want to have the first 2. So the adaptive clearing and the bore. Oh, Ravenkeeper. I mostly do 2D pocket on holes with multiple depths. Never use bore too much, really. I'm no cam expert. I use bore so far. It works fine, but I think it doesn't make a huge difference, to be honest. Because like both will, like bore is just literally like the, you see it here, it just does this helix motion. I like going in from the side onto the contour. If I can, that way I don't have to ramp or plunge into the other. What do you mean like from the side? I tried the plunge before, but this is not really like nice. I mean, it works, but it's not nice. Then the second program is this one here, only the bore 8. And this is after we removed the clamps. Technically, we can just do it in one operation, to be honest. You know what? Let's do this in one operation. So in the 0 bracket, I will also select this because we have the tool already on. So that's fine. Then this one is another NC program. And this one we use call 2, and the end mill is number 70. Okay. And then the last one is the chamfer. And that's number 3. And the tool is 1. Okay, now I have my 3 programs here that will create 3 G-code files. And what we can do now is we can simulate this program. Let's maybe try this again a little bit slower. So it will do the adaptive clearing here. And this will take, according to Fusion, 3 minutes. I feel like usually takes longer. Looks mostly the same, yeah. 2 secs. I'll send a pic. Okay, send me a picture. No, it's a bit too slow. But yeah, it does the thing here. And then it does the bore. And then we do the bores here. And then we have these all done. So it's the first program. The second program is we remove the clamps. Important. And then we basically do this ramp thing that Ravenkeeper doesn't like, but I think it's okay for here. And then the last program is the chamfer. This one's relatively straightforward. It goes 1 time only. I wanted to do 2 times, right? Because I had this finishing overlap. Ah, wow, that is not what I thought it would be. Okay. Well, technically, I can post these 3. So if I now say post process here, it basically poops out 3 G-code files. This one has an error. Ah, now it's green. Okay. Going to do it again. Yes. Okay. And then I can just, that's what I do every time I change something in program. I always just post all the programs, and then I all upload them again. And now basically I have 1, 2, 3, 0 bracket G code. And these we can basically print. I am quickly waiting for the picture of Ravenkeeper. Ravenkeeper sent a picture. Ah, you have this. Yeah, I tried that. Ravenkeeper. Let me quickly show what he's doing. So he's for the contour, not doing the ramp. Oops. But then has the lead in distance here set to 10. And that gives a little of a different. But then I also have to do multiple depths because otherwise it would cut the full 5 millimeter in one go. And for me, what happens with this, like with this motion here, is like it always hits quite hard for me. But maybe with what you do, the lead in 10 millimeters, it's better. I think I will keep it on ramp for this one though, because there's not really any overhead from the ramp, I think. Check. Yeah, no, I have it on ramp. Yeah, this one I post again quickly. Why is this now? Like one of them is always yellow. Why are you yellow? Because this one has no problem. Now I destroyed it. What did I do now for it to be so unhappy? Yeah, it's how much the lead in is like smoother. I think that helps a lot. Can I? See, now I messed around with it. Now, like, something is messed up. Amazing. Oh, wait. I'm missing completely the program for this now. No clue what I did now. Okay. And this has the ramp. Let me quickly simulate it again, just to be sure. Oh, also for this one, I want to have the bottom minus 0.5, just to make sure that we really cut through the whole material. Okay, let me post these three again, and hopefully I get 3 green check marks. Okay. Then I will upload the 3 again. Oh, now I uploaded them to my Voron 2.4. Okay, let's put a tool on, and then I think we can start cutting. So for the first operation, we need the 4 millimeter end mill. I was looking for the correct box for this one, but for some reason I don't find it. It doesn't matter. Okay. Okay. And then you know what? We can use this is the cable we added last time for the probing. I will just wrap this. We need to make this nice at some point, but like I just wrap this now around the tool. And this one I will just hold on the material, and then I think we should just be able to probe that. So I will just go to 0, 0. Let's do 30. 30. And arguably, this is not how it should be done. Like, we will make it nicer. But what I can do now, I hold this here. I didn't have this all. Welcome to the stream. I have like 10 injuries sitting in the garage right now. I'm super interested in this. Well, 10 Enders 3s. You can build a lot of CNCs with that. So I'm just holding this here just to make sure this works. So I'm a little bit afraid about that still. Let's see how to do that. So I hold this here. I will say probe, and then the tool will move down, and I will hover with my cursor over the emergency stop. Yeah, but you see it moves back up again. So probe triggered. So that's good. So we can just wrap this around the tool, hold this down, and then hope for the best. Perfect. So I still have to macro this a little bit, and like we need to like make some hardware for this. But we successfully found the 0 point. That is quite wild. Yeah, the magnet is printing, Ravenkeeper. It's printing. It's printing. Okay, but like basically, I still have to write a macro for this, but like the Z position, you don't see it. It's 6 point. It says 6.93. So this is now basically, I will move now to this Z. Oh, no, no, no. It is now exactly on 0. I have a 4 millimeter offset for the Z probe configured. Never mind me. The tool is physically right now touching. So if we're looking here, like this is touching. We are now at 0. So all I need to do, you notice I'm not like super routine with it yet, is we say 0Z, and then basically now Z is 0. Yeah, it's a very rudimentary probe. So the idea is basically, that's what Ravenkeeper is referring to. I'm making this part right now. I'm printing this. The cable, like this failed. The cable goes in on the back. There's a magnet on the front, and then we can just snap it onto the tool or onto the spindle. And then we make a small aluminium plate with an M3 hole, where we basically use a screw to fix the other half of the cable to. And then we can just place the aluminium plate here, let the tool move to the aluminium plate, and we get a 0 position out of that. That's also why I have an offset. Yes, I use Clipper. Never seen, well, this is a very special CNC. We use Clipper. Comes with some benefits. Okay, let me move that up. And I think we are kind of ready to fire, right? We have our 0 position. We have the tool installed. we do not have the dust shoe installed. Let me kind of like back this out of here a little. See if I can. Ah, it just doesn't work. Let me put that back on. I still have to order thumb screws for this. Also important, like we need to have this at a height that doesn't collide with anything. Once the clamps are, just making sure this also goes over the clamps on the back, but yeah, easy. Easy. I would make a spring clamp with two magnets and a wire. Yeah, Steve, that's exactly the plan. It's the spring or like the thing is printing right now. I printed it, and I, by the love of God, I have no clue where this thing ended up. I have suspicion a little thief stole it. Okay, that is connected. The vacuum cleaner is already automatically on. So I think we can just fire and forget and hope for the best, right? I zeroed. We upload a program. Okay, that is a success. Hmm. That is a success. I have to change back to autofocus. So we have the holes, and that worked quite well. So basically, what we should now be able to do, if it really worked, I mean, visually, it's over the holes. There's quite a lot of gunk in there. But there's a bit of friction. But I on purpose made these holes very tight so that I can recreate the position very well. But it works. Oh, this one is easier. And now we can remove the clamps. I'm actually super happy that this worked. Like, there was a non-zero chance this did not work or would not work. Let me move that a little bit over. Also remove the last clamp here. Okay, so this is clamped in place. We have all the holes. So now we can move over to the 6mm end mill and then do the contour. Ah, the collet adapters stuck in here. Oh, and Gravekeeper, yeah, I do have a chamfer bit, and we will chamfer that. The only thing that I now just now figured out, we cannot chamfer. We cannot chamfer these right now because there are screws in. So I might have messed up the order there. Maybe it would have been easier to change the tool. Sometimes the camera cuts out. I think my HDMI adapter is giving up. Sorry for that. Now it's cutting out a lot. What's up here? Very quickly. Let's come back. Yeah, let's see if that makes it better. But now we can also move the dust shoe properly down. Which means we will have a lot less chips flying around. Okay, and of course we have to find 0 again. So what I would quickly do is we have this little print here. Let me quickly clean it up a little bit. So that means this cable can go through here. And I'm not sure if I have them somewhere. I think I need to grab them. There's a space for 2 magnets in there. Gotta love magnets. So now the question becomes, how do we best put this in here? So I will just curl this up. And then I will just push the magnet in. And this should be somewhat of a press fit. So the idea is that this doesn't come out anymore. And yeah, something is wrong with my camera. Don't ask me what. I need to check that. But yeah, now I can just attach it here. Ah, fuck. We need some glue. A bit of glue is needed. So the challenge with glue is, of course, if you use too much glue now, we might disturb the electrical contact. So I have this brush super glue, which I love a lot. So I just brush a little bit on the side. And Then we push them in. Let's see. Hopefully, if this now, or when it dries, the magnets stay in and we do have contact. Yeah, but then the idea is basically you can just like snap it here. Not there, but there. Like it's basically needs to be on the, I tried before, this is not electrically conductive, only the spindle part is in the tool itself. And I checked all my tools. Okay. Let's do a quick check. So I can, the danger is now, if I do that and it doesn't work, that we lose our position. That would suck. So there's a bit of risk involved. How can I check this now? Oh, I know. Machine. In the machine tab, there are the end stops here on the bottom. Probe is open at the moment. If I now touch the aluminium plate, we touch it here on the back, it should jump to triggered, and it doesn't. So it's good we didn't try that. It's good we didn't try that live. So this does not work. Not a fun part. I think this is a loss now because I don't think we will get this magnet out. But why is it not working? Ah, with one magnet it's working. If I just have one magnet, the probe says closed. Well, my idea was with two magnets to make it hold stronger, but like seemingly this kind of backfired spectacularly. Ah, now it works. What? Yeah, this works. If I push it on the cable here, the probe changes to triggered. So this was not the issue. So now it's open, and if I touch the tool, what? Now it works. That's not confidence inspiring. Let's also try it with the aluminium plate quickly in the middle. Now it's open. Now it's triggered. Open. Triggered. Okay, it works. Last check. Open. Triggered. Open. Triggered. Wait, Ravenkeeper, are you telling me that I did something extremely stupid? Is this what you're telling me? I think it's what you're telling me. Okay, let's send it. Wait, let me position the camera so you see the failure close up. This is touching, and I send it. Yes, it works. Perfect. Now I can just snap this off. Like something is wrong with my camera. I didn't see that before, so I'm not sure if this is the first stream with these camera issues. But now we are at 0 again. So in the UI, I can say 0, Z. The XY coordinates didn't change. Let's see if I can move the cable a little bit in a different position. So technically, we are now ready to send the second operation. Cam issue was last time 2, I believe. Oh. Half the time, I don't even use my touch plate. Yeah, I mean, like, for me, it feels like it's less hassle to use the touch plate, but I'm not a CNC expert. Like, this is the first time I work with the CNC. I think I did something stupid. Because if we now cut this contour, I just paused it so we can resume it. If we can now cut the contour, the outer part is completely loose. Like this section here is completely loose. And I believe also on this side, we will have a little bit. Yeah, I can resume. I can resume. There's a little bit of material here, but this plate here will be completely free. I can't tape it down anymore. So I think what we should do, I will just cancel that job. And I will just quickly like change the contour here to have tabs. And I want those maybe 1.5 millimeter high, yeah, whatever. I want triangle. And can I get rid of all these tabs? I just want to have one tab here and one tab here. That it looks like this then basically. Then we have 2 tabs just holding this plate. And this doesn't like fly around. And then these parts on the side should also be fine because they are. I'm not sure if they will be connected. They will be just barely connected. So I think I want to have also one tab on each of these sides. They're like very quick to remove. But then like we have the peace of mind. Like it doesn't show the tabs here because as far as the CAD software is concerned, there's no material there, but it does the movement. Yeah, tabs. Jack in the shop. Tabs it is. So I not place a lot. it should be fine. And now we see basically this program here has now like an error because it's out of date. And now we can just post-process this. And then I can upload this number 2 again. Actually, it will like show error. So I have to cancel that first. I upload that. And now we can try it again. It will just start over, but like nothing will happen from starting over. But Ravekeeper, I fixed the pause macro. So for me, I can pause and I can resume. That works perfectly fine. I can give you my fix later if you want in Discord. Yeah, let me move the camera, spindle, and then we see each other on the other side. Okay. We are not 100% done yet. Here's a bit of material left. You see it there behind the tab. But I'm quickly just removing this corner. And with the magic of resume, you will get these bits, Raven. They're actually not expensive. One is like 10 euros, 12 euros. I have them from a German company. Yeah, so I think that worked really well. And that's still very well attached here. There's a little bit of material left, not quite sure why, but that's not a biggie to remove. I think when they dive in, like maybe there's a bit of resistance, but this is quite well attached still. Like there's no wiggle, so that's good. It's quite hot, which is like not hot, but like warm to touch. So what we now need to do is the chamfering. I kind of fucked up in the order of things. We should have chamfered these holes before we remove the clamps, because now I cannot chamfer them anymore because of the screws. So what we will do is we will change our chamfer program to first chamfer the edges around, and then we chamfer one hole at a time, and I will just remove the screw in this hole when we run the program. So let's go to Fusion. So for here, we have to remove these three. I mean, technically, we can already start chamfering one in the same operation, right? So this is the first operation. Then we make a new chamfer operation for the center one. And then we make a new chamfer operation for this one. And then while we are at it, here, let's also chamfer. I'm not quite sure if this will work, but Fusion will tell us if there's a collision. And this one we can also both chamfer. And then this one we can also both chamfer. So let's do a quick simulation on this one. Simulate, simulate, simulate. So this will do that. But it doesn't seem like there will be any collision or anything. So that looks good. Also, it's green. Otherwise, it wouldn't be green. Import shipping will kill that for me. Yeah, that might be the case. Yeah, like I actually not sure if you saw it. I reduced the feed rate to 66% in Clipper, and man, there's quite a lot of like material now here. I reduced because it seemed a bit too fast, but it doesn't sound bad yet. Like there's not a lot of chatter, so I think I can send it faster. I'm just like a bit cautious. Okay, so the first operation, we need to remove this screw. So let's quickly create programs for those. Let me quickly copy the name. So this one needs create NC program, and then this is number 4 and number 1. Okay. And then this one is create program number 5. Okay. And then we just post-process these 3 programs, 3, 4, 5. And I will quickly upload. Yep. Didn't save them for some reason. Let me quickly post-process them all again. Now it pooped them out. Now I will upload all of them. It's also quite nice, actually. Like you see in main sale, the check marks are removed, so you know actually which one. If you upload it correctly, it removes the check mark. So we need to do 3, 4, 5, and for number 3, I just want to double check quickly in Fusion. So for number 3, if I simulate number 3, it's not very slow. I have the contour and I have this hole, so we need to remove this screw here. Still fixed with 2 screws, so nothing bad will happen there. Okay. Then we need to change the bit, of course. And we need to find 0 again. So every time you change the bit, you do have to find 0 again. Because like depending on how far in the bit you put and stuff, like it's every time it's different. See if I can move that up a centimeter that the thing falls out. The camera is really bad right now. I'm really sorry for that. Yeah, so it's just a bit life reduction. It might gum up and snap the worst case, but for 10 euros, it's not that bad. Yeah, to be honest, like I mean, it works fine, and the surface looks really good. That's why I'm like, I also used the 66% on my last attempt. Let me quickly clean. And it creates quite proper chips, so I'm not very concerned about that. Okay, let me quickly maneuver this. Okay, I will connect that. And then we can do our probe again. That works really well, actually. Like I'm very happy how well the probe works. And then we can 0. And then we are ready for our next operation. We did remove the screw, right? Did we remove the screw? Yes, we removed the screw. So we are ready to send that. And that leaves us with a very pretty chamfer. The only thing that I maybe want to do is like also on the last program, let's quickly update that to also chamfer these like holes here very, very slightly. Actually, we can chamfer them just in the same thing. Let's quickly do that in Fusion before we continue. So the last chamfer operation, I just extend that. Oops. Also chamfer this, 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 and this. And then this one, the number 5, we post-process. And then number 5, I upload. Okay, so what I need to do now is move this out of the way. We put the screw back in. We put this screw back in. Or did I use the wrong screw? This one is too long. It didn't bottom out. There's the center extrusion here. The other holes are like empty on the like free below. Okay. We said this one. Let's quickly check in Fusion the simulation. So we are running program 4 now. Let's simulate that. And it should do this hole. Yeah. But I also, oh yeah, it does too. Okay. So we run program 4 now, which means we need to remove the screw here, which was the one that was a bit hard to turn. Oh, actually, now it's better. Maybe there was just some gunk. And like the enclosure keeps most of the dirt in, but not all of it. It doesn't close properly on the bottom. It's something I still have to fix. Okay, let's send the next operation. I'm literally an idiot. I'm literally an idiot. We chamfered now with 0. Which, I mean, you can do. It's a lot of fun to do, but it has 0 effect. I forgot to set the chamfer width from 0 to 0.3. So 4 and 5, we need to post-process. Yes, post-process. And then 4 and 5, I have to upload again. And then how about we just try the whole thing again? Okay, second attempt. So that also worked. That also worked. Now we have to remove the last screw. And then we can run the last chamfer program. Hey, Ravenkeeper, I think that's actually a really good idea to just try to remove this this plate here. To remove this and then just let it do that. I think it's a good idea. I like that idea. Let's enact that. Let's make that happen. Because otherwise, like, I have to manually do that. Then the question is, like, first I have to change the tool. And I'm not quite sure if I want to cut 1.5 millimeter in one go, so I think I will do like a small spiral. I should have done it before chamfering. That's actually a very good idea. Animalistic Tech, welcome to the stream. Yes, that's a work holding piece that will go here in the corner. The only thing is now we need to touch somewhere on this piece, so we need to be somewhat precise where we maneuver, but like actually we can just go to, let's say 20, 40. Nope. That should be good. Then let's quickly attach our like makeshift thing. I really need to check this camera. I'm touching the other half here, and then we can do our probe commands. Okay. And I will make a macro for that also zero sets zero then and stuff like that, but that is all like comfort. Okay, let's quickly do what Ravenkeeper suggested. So I really like this idea. So we know the tabs are 1.5 millimeter tall. 1.5 millimeter. So let's just do a ramp. I don't want to cut it in one go. So I do this one again. And the stock top height is not stock top, but it's offset of stock bottom. And then we do 1.5. And this is minus 0.5, which is also like what the others. And actually, because like a little bit was left there, let's do 0.7 just to be sure. And I forgot the ramp. I feel like the ramp gives like a nice finish. It's a very quick ramp, but oh, we also had the I'm not sure if it makes a difference. The maximum ramp thingy there is 0.8 here. I'm not sure if this makes a difference. Most likely not, because we only cut 1.5 millimeter. It does make a difference, yeah. Okay. Then we create an C program. I quickly want to copy the name here. And this NC program has tool 70 and is the 6th step. Okay, I could have clicked post. That would have been a smart move, but now we post manually. And then let me upload that. It's uploaded, and now we can send it. Very cool. You seem to have a pretty good understanding of CAM. Well, like not really. Like I'm learning as I go. I did manufacture the spoil board and stuff like that. So like I did some programs before. It's getting there step by step. Sometimes I think I had a stroke with typing. Why is it showing the chamfer tool? Because I had selected the chamfer tool. Thank you. I have no clue how that would. I mean, nothing would have happened actually because the chamfer tool cuts as well. Thank you, Ravenkeeper, for paying attention and preventing me from making stupid mistakes. Yes, post-process. I upload that again. To be honest, it would have worked perfectly because like there's no difference from the tool from a program perspective. But a good catch. Good catch. We zeroed that. We have XY coordinates. Let's send it. And that's it. We have a finished part. So the idea basically for these holes is that these are M5 holes. I need to tap them. I don't have my drill here to tap them, but the idea is basically to tap them. And then I can use like a screw that also holds down the workpiece here a little bit. I stole that design from the Cavera CNC. That's kind of like the work holding thing they deliver with their CNCs. And I thought it's a very like cool design. Still a foil on the back. I removed the foil on the top already that we can use it for the probing. Look at that. That's not a screw I want to use for him. One more of those. And now I know that, I mean, later I will measure this point, basically. And if I now put like some stock in here, like this, I don't have to measure this 0 point. I always know where 0 is, basically. What's interesting is that this doesn't sit flat. I think it's because of these like tabs here. Yeah. Now what I can do is simply this. And I don't think I even need the second clamp. Just for good measure, could we put one here as well? Move the CNC over a bit. And now this is properly fixed in place. So yeah, this is kind of like what I wanted to do. I think there's a hair higher because it still has the foil on the back. The spot was actually was spoiled, but could it cause workpieces to not sit flat all the time? Over time, for sure. I mean, right now, I only have this contour here, and this sits on both sides of the contour. But like, if you do it a lot, yeah, of course. That's also why I have this like two kind of like level spoil board. Like this one has all the drive-in nuts on the back, so for the screws to like screw into. It's a lot of work to like do that. So I don't want to replace this one. I only want to replace this flimsy MDF sheet. And machining this one is like maybe like 20 minutes of work. And then yeah, you have a new one right away. I only have to quickly cut it to size. What I do is like I just use a bit of spray glue to fix it down. I also try just having like 2 clamps here in the front. Yeah, and then like I can just plane it, surface it, and then do the holds, and then like I'm done. Because I can reset the machine into the coordinate system of the spoil board. I have a G-code script basically that homes XY and then moves or like sets the coordinate system of the spoil board, and then I can just rerun the spoil board program I still have on the CNC. So it's relatively straightforward. Yes, so for this thing, let me look at the time. Looking at the time, I kind of have a deadline at 9 p.m., which is pretty much now. So I think this is as much as we will do for today. It's always like incredible how long it takes to machine these things. I totally underestimate that. And my plan is to machine parts for my Warren 2.4. Like I want to have a metal gantry and I want to make it myself. That's the whole point. At the moment, I'm a little bit skeptical on that. Like I built this whole machine for that, basically. Like not only for that, but it was kind of like one of the projects I had in mind. And right now, I'm a little bit skeptical about that because the machining time is quite long. So I think I will need to spend a bit of time on getting the speeds a little bit like tuned in, just like to see like, because the ramp I did now here to like cut this was definitely not as fast as the machine could go. So I think it makes sense for me to first like get the machine a little bit better under control, so to say, and get a little bit more experience before I like start like a big project like that. Because I did like a very rough estimation, and it will take like Fusion is always like telling me times that are not really aligning with reality. But for Fusion, it's like basically 3 operations I have to do, like 3 plates I have to cut, and each plate, according to Fusion, takes 1 hour. I know that the time Fusion gives me, I have to multiply by roughly 3 to 4. So if Fusion tells me that these operations take like an hour, in reality, also with tool changes and everything, I'm like busy for like 5 to 6 hours. So I need to. It will take me a while to do it because I'm not sitting here for 6 hours like using the CNC. Also because like it's quite loud. I do have a cat which I can park for like a couple of hours somewhere at my neighbor. So that's why Loki isn't here. He is not a big fan of the CNC. So whenever I use the CNC, and I think it's mostly the vacuum cleaner, to be honest, because like 95% of the noise I have, maybe 95 is a stretch, but like maybe it's like 60% of the noise I have comes from the vacuum cleaner and like 40 from the router. So yeah, I can park him for a bit, but like I can't park him for 6 hours straight. So I think I need to kind of like manufacture those parts over multiple weeks. So it will be quite a journey. Making your own Warren CNC parts will be epic. Yeah, like I really look forward to that. I kind of want to machine the parts for V0, for my V0. But there are no open source parts for the V0 to be machined. Like for 2.4, there are 2 projects on GitHub that have like CNC parts for 2.4. I'm not 100% sure which one I take. There's the monolith gantry, and there's Vitaly, who has like the 2.4 CNC stuff. He also sells those. And I'm not sure yet which of the 2 I will go for. Vitaly is more like a drop-in solution where the monolith is like really like a mod. But I also want to install like a bond pack index system on this machine as soon as that becomes available. Actually, today they started the pre-sale of the Prusa Core 1 upgrade with the index. So I think at some point in the next weeks they will also start like selling the like DIY kits. And I kind of want to like wait until I have the index and first to the index, because then I know what restrictions I have there for the gantry. I think it makes more sense to first get the index in and running before I do like the CNC parts, because if I now make the CNC parts with a lot of effort, later they are incompatible with index for whatever reason, that would be quite a shame. Yeah, so that is yeah, as Ravenkeeper says it, like another successful stream. It's the third in a row. I wouldn't call it a full success though, because the first 5 minutes was without sound. So let's call it 90% success. Cool. But yeah, I'm really happy with this. Let me show it off one more time. Like this worked very well. It looks cool. It's functional. The only thing that concerns me a tiny bit is like there's like a little bit of a gap here and it's not super even. So I'm not 1000% how straight this is, but this is not a high precision machine. Just to be very, very clear, this is not a high precision machine. This is a machine that I use to make my parts. And if I achieve 3 print accuracy with this thing, that is pretty much all I need. Loosen this up. Can I move this? Because here there's like a gap on front and the back. Maybe there's also some chips in between or something. But yeah, you see, like actually now, even with it being loose, it doesn't fly off. I have to loosen this more. I really like these clamps. The clamps are amazing. No, this is flush. No clue where the problem here is, but I will figure this out. Okay, cool. Perfect. Yeah, then let's not spoil the good stream. Thank you everyone for tuning in. And yeah, enjoy your weekend and see you next week. Oh, by the way, next week, I think, I'm not sure if we will need another stream on the CNC because it's pretty much working, as you can see. I did order a MMX MMU kit, so potentially we'll start working on the MMX next week. So that's just as a small heads up. Cool. Then enjoy your weekend. See you next week. Bye.